Hello everyone, this is the video number 2 about the power supply. As we say in the first video, now we're going to talk about the switching power supply. The first part we talk about the linear simple circuit of the power supply, the basics, transformer, diode and capacitor, or transformer, rectifier bridge and capacitor. So this video we start about the switching power supply. The power supply that we find it in any device, and this is our examples of the power supply. Here, switching power supply from the rectifier bridge and up to the capacitor of the output. If we take the power direct to the rectifier bridge and we don't use none of this, the power supply it will work fine. So that's why I said we start from the rectifier bridge to the output capacitors. The basics, you're going to see it in any switching power supply. There is rectifier bridge, there is input capacitor, there is switching IC, this black little IC here, there is a MOSFET, there is a transformer, output diode, and output capacitor. This is the thing that you're going to need to remember. So from the input, this is the source of the power, rectifier bridge, input capacitors, two MOSFETs here. The two MOSFETs, they have switching ICs here, transformer, diodes, capacitors of the output. All the TVs can work with the same basics. The input of the power here, all the way to the rectifier bridge, MOSFETs, capacitors, switching IC, transformer, output diodes, capacitors. That's a plasma TV. This is a LED TV. Rectifier bridge, transformer, capacitors, MOSFETs, switching IC, this one's here, diodes, capacitors. Any board, same thing. Any board you're gonna find rectifier bridge, capacitors, MOSFETs, switching IC, transformer, diode, capacitors. Here too the same thing, but this is the rectifier bridge is here. You can see them here. MOSFETs, switching IC, the input capacitors, transformer, diodes, capacitors. All the same. So I want to show you all this, that you can know, if you understand the switching power supply, repairing power supply, it will be more easy for you. So let's talk about the component that I show you in the board. The first thing that the power goes to is the rectifier bridge. You know from the first video, the rectifier bridge, what it does is flip the wave from the bottom, flip it up. That's all the rectifier bridge do. So here, 110 volt AC, and we have a rectifier bridge and the input. So this is the positive. For you to be easy for you to understand the rectifier bridge, the positive side, the two diode is face the positive side. The negative side, two diodes is facing the other direction. So this is a positive, this is a negative. 110 volt AC. When it's come here, it's become 160 volt, and is a DC. Is no more the wave and the bottom. The wave is up, still not a line, but all the waves, all the top of the waves is on the top. And like we talked before, so this is, if we put the oscilloscope here, we're going to see the wave is going like this from the positive 0 to the negative. That's the top of the wave. In this point, we're going to have the wave like this, but it's not going to be in the bottom. The wave is going to flip it up in this point. That's the rectifier bridge, the same as the linear power supply. If you remember here, the wave in the bottom is flipped up. The difference between the linear and the switching power supply, the rectifier bridge in the linear is in the output of the transformer, and the switching power supply, it's here in the input. You can see this is the primary side of the transformer, this is the secondary side of the transformer. So we did talk about the rectifier bridge, this part here, the 4 diodes. After the 4 diode, we have a capacitor. And for us to be sure, here you can see the positive side of the capacitors. The positive side of the rectifier bridge is connected to the positive side of the capacitor. The negative side of the capacitor is connected to the negative side of rectifier bridge. So we have this wave in this point. So in these points, we are going to have the wave like this. It's close to one line. So this is a positive voltage, and this is a DC Moore filter voltage. But here we have we still have 160 volt. So we want this voltage to go down to 5 volt standby. So let's stop at this point, and we're going to talk about the MOSFET. So a diode here, and there is a diode here. So this is a source, this is drain, and this is the gate. So how the MOSFETs works? So there is a voltage is coming from here, and it stopped at this point, cannot pass to this side. If we want this voltage to pass to this side, we need to give a voltage. This is a V gate. This one we make it name VS. So like here, the voltage usually here, if we say here 160 volt, that's voltage is stop here. V gate should be like 5 volt to maximum 12 volt. If we play with this voltage, like turn it off and on by using a switch, like turn it on and off to make this wave. This is T1, this is T2, this part here. This is from 0 to 5 volt. We see from 0 to 5 volt here. That's the voltage that's going to the gauge. We are going to have, every time the gauge has a positive voltage, is going to allow the voltage to pass to the drain, to the other side of the MOSFET, to VD. Let's give it a name, VD. So here we're going to have 160 volt, and is a AC, one line. In the VD, we're going to have from 0 to 160 volt, but we're going to have the same shape of this wave. It just, the wave is very big. Here from 0 to 5 volt, here from 0 to 160 volt. So this is T1, this is T2. The same time from this point to this point is you're going to find it from this point to this point. So that's what the MOSFETs do. On off here, we're going to find on off here, and this is what we need here. We need 5 volt, which in IC, or another name, oscillator, and we need a MOSFET. So let's put a MOSFET here. So for this MOSFET to work, we need a switch-in IC. This chip is connected to the MOSFETs. Let's check it. Here, it's connected here. This is the gauge of the MOSFET, is here. So from this switch-in IC, this one's here, that's the one is making the on-off for the gauge of the MOSFETs, and we have the MOSFETs here. So this is the source, this is the gauge, and this is the drain. So from the drain is going to go to the transformer. The other side of the transformer is going to connect to the negative side of the capacitor, and we're going to have, that's the primary, and we're going to have a secondary side of the transformer. So I make this coil small just for you to know the size. If we have a big voltage here, the transformer is going to transfer it to a small voltage here. We said at the first we want 110 volt AC to become a 5 volt DC. Where we put the MOSFETs turn on and off here, because as we said in the first video, the transformer doesn't work with the DC. We have a DC volt here, like a line. Transformer is not going to work with that volt. Transformer is need a voltage that's go from a positive to 0, or it's go from a positive to negative, go all the way like this. In this case, the output of the MOSFET, the voltage here, is going to have this symbol. It's go up and down, up and down. Depend the wave here and the input, the wave in the gauge. This up and down, the transformer is going to transfer it to the other side. If we have 0 to 160 volt here, we're going to have a wave from 0 to 5 volt going up and down. We're going to add a diode here for the filter to don't let the power go on the other side, and we're going to put a capacitor for the filter, and here the capacitor is going to fix the line. It's gonna filter the DC. We're gonna have like this, then go up, something like this. This is 5 volt, this is 0. This is a sample basics just for you to understand. I'm trying to make it more basic to understand the power supply. So next video we're gonna talk about the switching ICs. So that's enough information for now. Just we keep it simple and see you on next video.